So, for these past 3 months, I was stationed in Gleason, Tennessee for a company called Emirates. And from there, when I joined the Emirates team, I was supervised by Tate West, who is the regional environmental specialist there. And with Emirates, they mainly work in the production and processing of industrial minerals. And at the Gleason site, they mainly specialize in clay and their different grades. But at different other sites in North America, depending on what region they're in, they specialize in their own type of mineral. One project that I was conducting during my time there in Gleason was, is there a different way of calculating flow rates? That was the main project that was assigned to me by Tate, and from what he told me, the method that they used was using a 5-gallon bucket test to calculate their flow rates. But that was before we were showed by David, the mine engineer, on their new contraption, as you can see from the picture, and other mine supervisors that helped him create it in creating and capturing a larger volume for calculating flow rates. So from afterwards, I was instructed to research possible new methods that weren't electrically based, or we can use any other type of method. And from that project, I was able to use the knowledge that I gained from my past few lectures and labs, such as fluid mechanics in the lab and my intro to environmental engineering class. And from there, I reviewed my class lecture notes and labs from fluid mechanics that dealt with the flow rate section to help me connect it to real world situations. And from my further research from developing a different type of flow trackers was either using electricity as a power source that was movable or mobile, or using some kind of rechargeable battery, or redneck engineering, as my coworkers called it. I haven't quite finished it yet, but it's still in the process of researching a little bit more and see what better fits. Another project that I was given was from the mine site engineer. Not mine site engineer, but the mine site manager. His name was Michael, and it was mainly dealing with cost analysis. And the problem that he mentioned to me is that they stumbled upon this summer was that the Gleason site went past their budget of the chemicals that they used to clean out their water collection ponds, and the chemicals that they used were soda ash and aluminum sulfate. So, from this mini assignment, I was asked to research any other possible new alternatives for the water treatment done in the water collecting ponds at the sites. And from this, I was able to use the knowledge that I gained from my past lectures, such as cost analysis and the intro to environmental engineering. Even though I didn't use the proper techniques that were shown to us from the cost analysis lecture, it did aid me in reading the cost sheets that I was presented from one of the engineers there, and to think more about the money behind the scenes. And from the intro class, Intro to Environmental Engineering, it helped me with the terminology and the understanding of the process of coagulation, which is the main objective with aluminum sulfate in their collection ponds. As stated on the past slide, I haven't quite finished looking into new alternatives, but we maybe there's a possibility of finding a cheaper and effective method. And the another project that I was able to help on were the well elevations around a new site that Gleason had bought. And but they experienced some problems with unexpected water issues. I was given this mini project from a geotechnical engineer named Linda, who spent her time there to see if she could come up with a solution with them while she was on site there. And so I was instructed to gather information about the nearby wells, such as the elevation, static levels, and elevations of these static levels. And from this project, I was able to use the knowledge I gained from my fluid mechanics lab because of the usage of Excel when it came to showing my calculations. And from my data collection, it was concise and easy to follow through with my Excel spreadsheet and my supporting diagrams. But what also helped me was, and when it came to presenting my work and findings, was from the procedures that I gained from my fluids and materials of construction lab when it came to submitting our final draft of our work. With this project, it was very helpful to the mine engineers there in executing a better plan. Not better plan, but determining a plan on how to approach this new mining project. But overall, for my time being for being in Gleason, Tennessee for my internship, I was able to be part of a group project with a legitimate company and getting to travel to different sites to view different methods being used for discharge. And I was able to form connections with my coworkers and possible references. But overall, I learned new techniques to gather data by using specific sites I did not know could be useful. And with these projects, it helped me in furthering my knowledge that I gained from my past lectures and labs. But overall, this experience was very useful, hopefully for me in the long term. And that is it. Thank you.